Let's take a look at this question. It's asking us to calculate the definite integral from 0 to 1, from x equals 0 to x equals 1, of 6x times 3x squared plus 2 with respect to x. So in this situation, one thing we could do, if we wanted to, is we could actually just simplify this. We could do just multiply that 6x into the 3x squared plus 2. So let me show you what that looks like. I could, if I wanted to, multiply this in. And this would be the exact same thing as the integral from 0 to 1 of 18x cubed plus 12x dx. And then I can use my definite integral rules and split this up and make it simpler, and then use a fundamental theorem of calculus and continue as I have in the previous examples. But I don't think I want to do that. Instead, what I'm going to do is I'm going to do the substitution method instead. So let me show you how that works. So I'm going to do the integral from 0 to 1 of 6x 3x squared plus 2 dx. And then what I'm going to do is I'm going to try to choose a u so that it makes my integration simpler. So the u that I'm going to choose is going to be 3x squared plus 2. So let's let u equal 3x squared plus 2. So now if I write my integral, I'm going to go integral 6x, and then this 3x squared plus 2 now is just u, and I have this dx here. Now I want to get rid of the dx, so let me just copy this down for a second. I want to get rid of all the x's. I have x's and u's all scrambled up here. So what I'm going to do is I'm going to go over here. This is just standard substitution rule stuff. I'm going to take the derivative of u with respect to x, which just gives me 6x. And then I'm going to pretend that this is a fraction, even though it's not. And I'm going to try to solve for dx. So dx is equal to 1 over 6x du. And then what I'm going to do is I'm going to replace my, anytime I see a dx, I'm going to replace it by 1 over 6x du. So now I can go into my integration. This is 6x u, and this dx now is 1 over 6x du. And I cancel off there, and I cancel off there. And now I have an integration that's only in terms of u. Now, our boundaries of integration up here, we're going from x equals 0 till x equals 1, and now we have an integration with respect to u. So we have to change our boundaries so that they are in terms of u. So when x is at 0, what does u actually become? Well, we look up here to our definition of u, and when x is equal to 0, 0 squared times 3 is 0 plus 2. When x is equal to 0, u is equal to 2. So our lower bound for our u integration starts at 2. In our upper bound, we had that x is equal to 1. When x equals 1, we have 1 squared times 3 is 3, plus 2 is 5. So our u integration ends at 5. Now we're in a situation where we have the definite integral from 2 to 5 of u du. And now this is fairly straightforward to do. We can just use our the fundamental theorem of calculus and some antiderivatives to calculate this. The antiderivative of u is 1/2 u squared, and I'm going to evaluate that going from 2 to 5. And what this means is when I take 5, I plug it in wherever I see a u here, so I have 5 squared. So let's write that better. I have 5 squared minus what I would get when I plug in the lower boundary here, when I plug in 2, which would be 1/2 2 squared. This becomes 25 over 2, becomes 5 squared is 25, minus 2 squared is 4, 4 divided by 2 is just 2. Of course, that ends up being 4 over 2, so the final answer, after I take care of all the fractions, is 21 over 2.